Then we continue to the next speaker. Øyvind Meinich-Bache has his PhD in image processing and deep learning from University of Stavanger. He is now working as senior data scientist at Lærdal Medical. In addition, he is adjunct associate professor at the University of Stavanger. Today is can AI support call handling in emergency medical dispatch centers? We will get the answer soon.
Thank you for the introduction. Yes, we will explore if AI can do this for us now. So yeah, as Tom mentioned, I work at Lærdal, and at Lærdal we have an ambitious mission. We aim to help save 1 million more lives every year by 2030. And in order to achieve that, we have different goals or targets, and one of them being improve survival in the community. And this is where emergency medical dispatch centers plays an important role. And their role is in the chain of survival, and this is what we're looking at here. It all starts with a bystander finding a patient. It could be a cardiac arrest case, calling for help, the emergency number. The dispatcher or call taker at the dispatch center answers the phone and guides the caller and choose to or decides if ambulance is needed and if the patient needs to be transferred to the hospital. But research has shown us that the largest opportunity to save lives for these time-critical emergencies is in these two first links here, before the professionals, before the EMS personnel arrives at the scene. So what these two, bystander and dispatchers, does together plays an important role as well. Globally, there are different needs. We have in Norway, for example, developed emergency medical service systems and dispatch centers. We see an increasing call volume and more use of video, so the dispatcher has more to pay attention to. He needs to look at the video from the caller's phone. The resources are stretched and not optimized. Other parts of the world have different challenges, like in the developing areas. They often have limited access to first aid and EMS service, and time-critical care is often delayed as a consequence. And sometimes calling the emergency number is more like ordering an ambulance rather than getting guidance. So what we aim to do is to make an AI system that could support both of these needs. And if we look closer to what a call taker at a developed medical dispatch center is doing, she or he is essentially a master of juggling in real time in very stressful situations. The caller could be very stressed. This call taker needs to document the incident, understand what the caller explains, and assess the patient's symptoms to decide the emergency type and decide the urgency of the response, should we dispatch an ambulance or not, and also provide first aid instructions. And this is, of course, a high cognitive load for the call taker or dispatcher here. And what we aim to do with AI is to offload the juggling, to support the call takers with auto-documentation, which is a big workload for them, and also with understanding the communication and the emergencies so that we can generate medical advices they can forward to the caller. So it's an AI assistant. And we can also provide the responders, being the ambulance or hospital, with information about what they will expect to meet. And this is what we have developed a prototype of. I'm going to explain it more, but the functionality is speech to text to understand what's being said, image analysis from the video stream from the caller's phone. We interpret patient symptoms from the image description and the transcript, and then we generate medical advice that are grounded in the Norwegian index, which is the protocol they are using when providing guidance. And we're doing the auto-documentation. And this means that the caller can focus more on the dialogue the call taker can focus more on the caller and the dialogue, and making the final decision on urgencies and steps to take. Here we see a screenshot of this web app, or how the user interface for the dispatcher or call taker could look like. To the left here we have the video stream. So this is a simulation case. It's a severe injury, open fracture with significant bleeding. We have done simulations. And here you see the caller's video stream. We see images we have analyzed by the AI to describe the injury and the scene. We have a summary of the situation that is regularly updated once the AI has more information on the conversation and images. And then we generate advices the call taker can forward to the caller, instructions on what is important to remember and do in this case. I'm going to show a 2-minute video that helps explain it. This is not a professional call taker. He's our app developer, so he's just following the AI instructions of the system.
Medical emergency, how may I help you?
Yes, hello. This is Elizabeth Smith. I'm calling on behalf of my sister. I think she must have fallen down from the sofa. She was unconscious when I came in here. I think she's broken her leg and it's bleeding quite a lot. Please send some help.
Okay, what's the address or location of the patient?
We're calling from Big Street number 1 in Stavanger.
Big Street number 1, thank you.
Yes.
Is the patient conscious and breathing?
She's waking up a little bit more now, and she's breathing a little bit fast and shallow, but she's breathing, yes. Mary, can you hear me? Mm-hmm. Yeah, she's opening her eyes now, yeah.
Can you keep the injured leg elevated to reduce the bleeding?
Yes, my mother is here, so she'll help me with the filming, okay? And can I just use a kitchen cloth or anything like that?
Yes, that's fine.
Okay, I have a clean kitchen cloth, and what did you need me to do? Should I just press, or what did you, I didn't hear what you said.
And then you need to elevate the leg as well.
Okay, just lift it up.
Mm-hmm.
Okay.
Is she experiencing pain in the head, neck, chest, or?
More information, and he chooses to analyze images, which we'll also put into the context when the advices were generated. So this is the technical architecture behind the system. We use Azure Communication Service for the communication between the caller and the dispatcher, also for the video part of it. We do speech-to-text transcription, and the AICoS server is, AICoS is the project name and the system name. The server there is the front end we just saw, and behind the scenes there are 3 main AI endpoints helping us here. It is ChatGPT Vision that describes the images, the injuries and situation, and there is ChatGPT LLM that put everything into context and generate the medical advices. And as I mentioned earlier, these dispatchers or call takers are using the Norwegian index protocol, telling them how to proceed in each emergency. So we need to make that available through a RAG service with a vector store. And the reason for making that available is because LLMs has limitations. When you ask very specific, detailed questions, like crucial advices for sepsis emergency calls according to Norwegian index, the model wouldn't know, and hopefully it says, I don't know, but sometimes it hallucinates, and that's a big problem because it's trained to try to answer you. So instead, we want to make, using RAG, which is retrieval augmented generation, we want to make this Norwegian index available for the LLM. So that once he gets a question he's unsure about, he creates an embedding of it, goes to the vector store and searches for matches for that embedding, and then retrieve the section that is relevant. And what is important for us is to retrieve, it's a big document, complex document, and we need to retrieve only the relevant portion to avoid bad performance or hallucination. So we're working on ways to optimizing the RAG system to make sure we extract only the relevant part. And so how do we test this system? We do automatic testing. We have test calls created at SAFER where we did the simulations. So we created fake injuries as well. So we have images and transcript. And this is an example of a transcript, and we make breakpoints at important stages in the conversation where certain questions should be asked by the call taker. And then at each breakpoint, we can have the AICoS system generate a summary and advice, which we can compare and score, meaning measure similarity using an embedding model. We can compare the generated advice with the expected advice, and with all the expected advice with the same priority. That means that if you go further into a conversation, it doesn't matter if you ask this before this, as long as you ask both in a way. So we want to check it group-wise as well. And then we can average over the entire conversation and then over multiple runs. And we could, in this way, evaluate and compare building blocks of the system if we replace the LLM or if we change the embedding model or something. We are working on this as well. It needs to be covering and fully automatic so that it tells us easily what works better than other things so that we can continue developing. But to answer the question, can AI explore and support call handling in emergency medical dispatch centers? We believe it can. This is a prototype that does the auto documentation, are able to generate medical advices grounded in the Norwegian index, and does it in real time. Of course, it's limited test cases we have done it with, and it need to be further developed. But we believe it has high potential for offloading in developed EMS system, but also to bring an AI expert into the developing EMS systems as well. So that's it. Are there questions from the audience?
Yes, there's a question. No?
Hi, thank you, very interesting. I'm wondering, how do you plan to market this or implement it into the market? Is Lerland planning to sell it as a product to dispatch centers?
Yeah, so Lærdal has a lot of partners and collaborators, and now we have spent a year on an explore phase, and now we're going into a conceptual phase together with Oslo University Hospital. So then the first implementation of this is to design it according to their needs, and eventually, gradually use it in real cases together with them in their dispatch centers. But there's a lot of regulatory stuff and things we need to consider on the way, so we are exploring all of that. But eventually it's a service that we can take, that can cost, for the dispatch centers.
Good. Another question here.
That was very nice. So Chai has a partnership with the Scottish Ambulatory Service, which is the exact equivalent that you have here.
Oh.
Of how to send, effectively think about sending an ambulance or telling the bystander what to do. We consider it an intervention, so basically try to look at will this improve outcome or not. One of the particular questions that they have there is whether they can send a special type of ambulance, particularly for stroke patients, because there are very few.
Yeah.
And you need to manage them very well, because there are only very few in Scotland. So my question is, where do you see the difficulty in translating this? Is it in embedding it within the EMS software? Is it with the bystanders? Is it with the operators? Where do you think is going to be the hardest part of translation?
Yes, so for the bystanders, they will experience the same because we're tapping into the dispatcher's role and prompting him with stuff and guidance. But it is like just by working with Oslo University Hospital and their systems and all the building blocks, how to kind of connect into it and allow the video stream from the caller's phone, like very sensitive data, to pass through our system so that we can analyze. So just the implementation of how to kind of implement it, and systems varies a lot in different regions of Norway and especially in different countries and parts of the world. So I would imagine that being difficult, and of course the training learning process for the dispatcher itself. For them it could be confusing. There's more things to pay attention to. So that's how it is with everything that's new. But of course we need to develop it together with them to make sure that we meet their requirements and needs, and that we have an implementation and onboarding plan that makes sense. But it's a bit of next step. So we have focused more in the explore and proof of concept phase up until now.